All right, let's talk about the Jahn-Teller distortion in a little bit more detail and see where it comes from. So the Jahn-Teller distortion will arise from any octahedral electron configuration where there's some degeneracy in one of the sets. And let's see what this means, this idea of degeneracy. So for a D1 electron configuration, I, in this way that I've written it here, have assigned this one electron to the XZ. So the DXZ orbital has the one electron. But there's no good reason not to assign that electron to the YZ or the XY. So this has a threefold degeneracy in where I put that electron. Spot A, spot B, spot C. And so anytime that you run into this situation, there will be some type of Jahn-Teller distortion that occurs. So three choices where to put the electron, and then in D2, three choices on where to leave the empty box. So I could decide one of these three should be empty. Could be either be the box that I left empty, could be this box left empty, or could be that box left empty with electrons occupying the other two. So this will also Jahn-Teller. So Jahn-Teller in this case, Jahn-Teller in this case. Here though, check this out. For the D3 electron configuration, I have one electron in each box. There's no degeneracy because it's completely full. And so this is no Jahn-Teller. Okay, this has no degeneracy because I have three electrons, I have to place them, I have three boxes to place them in, so I'm not making a choice to leave a box empty or to occupy just one of the boxes. Then once we get over here to D4, this is D4 high spin, the three bottom boxes are occupied, the fourth one goes up top, but why did I choose dz squared versus dzx squared minus y squared? And so this also is yes, it will Jahn-Teller distort. So I go on to D5. Now D5 is going to be like D3 was. So no choice. I have 5 electrons. I've been told that they all need to be up. It's high spin. So for high spin D5, one electron in each box, there's no degeneracy here. So this is a no to Jahn-Teller. Then for a 6th electron high spin, that 6th electron, I've had to decide where to put that down electron. And there's no reason that it's in XZ. It could be in YZ or XY. And so this has degeneracy in it. And so this will Jahn-Teller distort. For D7, I have one down spot that's empty. And so it could be here, here, here. So that one also will distort. When I get to D8, paired, 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 and 2 up, there's no ambiguity here. So this one, no, it will not Jahn-Teller distort. D9, well, the pair of electrons could either go in z squared or x squared minus y squared. So yes, it will distort. And this has all the orbitals completely full. So no, this one will not distort. So to remind you from the earlier video what these distortions are doing, so for example, starting with our octahedral levels, if we do a compression, everything with a z component will go up in energy, everything without it will go down. And so we'll get some levels that look like this. And for D1, D1 is really happy to do this because it gets to drop an electron in a lower energy orbital. So it would be in any one of these in an octahedral arrangement. Well, it distorts and drops the energy of one orbital. It's got one electron to deal with, so it does this. It does this axial compression. Whereas if we go the other way and we do an axial elongation, D2 is happy to do an axial elongation. And so basically all of these levels are going to flip around. Anything with a z component will go down in energy. So x, z, and yz go down in energy, xy goes up in energy, z squared comes down in energy, and x squared minus y squared goes up in energy. And so a D2 electron configuration would be really happy to do this. Well, what happens at D3? Why do we say there's no Jahn-Teller distortion at D3? Well, if we have a D3 electron configuration, it would look like either this or this, and that doesn't get us anywhere because as these split out, the 1 goes up by 2/3 and the 2 go down by 1/3, and so we haven't gotten any energetic advantage. There's no change in the energy for doing the distortion. We don't get any advantage from doing the distortion. Same deal here. If we go this way, we put 1 electron in each. This one goes down. This one goes down by 2/3. These each go up by 1/3, and so there's no advantage to doing it. And so it just so happens that it's these configurations where there is no degeneracy that you'll run into a situation where there's no driving force for the distortion. When there is some sort of degeneracy, then there will be driving force for the distortion. Okay, one final thing that we need to talk about. So the ones that I'll mark in red have a degeneracy in the top, in the EG set. So this D4 has a degeneracy up top. Where else do we have a degeneracy up top? Here at D9, the degeneracy is up top. And any others? Let's see. No, just these two. So for this one and this one, so if we have the degeneracy up top, the place where we have a situation where we have to decide, then if it is, so if it's in the EG set, it's something that's called strong Jahn-Teller. And if it's like the rest of them that are Jahn-Teller distortion, but it's down in the bottom, there's ones that I'll do here in green. So D1, D2, D6, D7. So D1, D2, D6 high spin, D7 high spin have the degeneracy in the T2G set, and that ends up being something called a weak Jahn-Teller distortion.